everyone, we are back again with another set of video, and today's our topic is electricity. We'll talk about why electricity is important, how it is important in our life. So if you all remember in the online classes also, all the students of Mumbai got 1 day holiday, and which was that day? This was that day, and you can see this was there in the newspaper that Mumbai signals, cameras go blank due to power outage, road traffic movement hit. Now, what does this indicate? That a city like Mumbai, a mega city, also faces such issues. And this has disrupted all of our life in that just 1 day. So what we get from here, that we have dependent ourselves totally on electricity. And that's why it's very important to understand what exactly is electricity and how it works. So when we talk about electricity, we need to understand the first term, which is electric current. So let's understand what's electric current. What exactly is electric current? We all know that every atom is made of proton, neutron, and electron. So let's see. So when we talk about every atom, it's made of proton, neutron, and electrons are revolving outside. When we talk about these electrons, the movement of these electrons basically is creating electric current. So when we talk about electric current is a rate of flow of electric charges. And we say electric charges, we are talking about electrons which are negatively charged. The formula comes out to be I equals to Q by T. Many a time students have a confusion that how electron move and how current moves. So let's understand electron, because they are negatively charged, they always move from negative terminal of the battery to the positive terminal of the battery. Whereas when we talk about current, which is represented with a symbol I, it always moves from positive terminal to the negative terminal of the battery. That is the convention which we are following. Coming up to the formula of current is I is equal to Q by T. I is representing current, Q is charge, T is time. You can see here, it's written here. When we talk about the SI unit of current is ampere. We represent with the symbol A. SI unit of charge is coulomb. We represent it with the symbol C. And SI unit of time is, as we all know, is second. So when we talk about the SI unit of current, it's ampere. And when we are asked to define SI unit of current, we'll say that when 1 coulomb of charge flows through a circuit in the given time, which is 1 second, then the current through a circuit is said to be 1 ampere. And the device which we use to measure electric current is called as ohmmeter, and it is always connected in series. Now, some of us may have a doubt that ohmmeter always has to be connected towards the left or towards the right, and what are the symbols, where to place positive, where to place negative. We'll talk about all of them in this full chapter. Let's go to the next topic of discussion. Next topic of discussion is potential difference. So after electric current, which is the symbol I, we come up to the next topic, next term. So after the discussion of I, we come to the next term V, and that is potential difference. So if you would have seen an electric cell, you would have seen there's a bulging end in the electric cell, the cell which is there in our remote. There's a bulging end and there's a flat end. The bulging end always represent positive terminal, and the one which is the flat always represent negative terminal. So when we are talking about it, between these two terminals, there is potential. And what exactly is potential? Potential is basically work done to move a charge. So much work we are doing to move a charge from one end to the other end is called as potential difference. Can also be termed as energy required to move a charge from one point to the other point, because work is same as energy, because energy is capacity to do work. So you can see this is formula for potential difference. And when we are coming up to the concept of potential difference in battery, the cell which we use in our remote control has a potential difference of 1.5 volt. Now, what is volt? Let's understand. Batteries lift charges to a higher potential. There is potential difference because each coulomb of charge has a different potential energy at either end of the battery. So when we are talking about battery, the difference in potential creates potential difference, and the formula comes out to be V is equal to E by Q, or W upon Q basically. So the SI unit of potential difference is volt. Potential difference is volt. SI unit of energy or work is joules, and that of charge is coulomb. So if I'll ask you, what is the definition of 1 volt? You can see 1 joule over 1 coulomb. So when 1 joule of work is done to move a charge of 1 coulomb from one point to the other point, the potential difference in the circuit is said to be 1 volt. So as we discussed previously, when we are talking about current, we use ammeter for understanding potential difference. For finding out potential difference in the circuit, we use voltmeter, and voltmeter is always connected in the parallel setup. When we talk about ammeter in series has low resistance and voltmeter has high resistance, and that helps us in understanding what is the difference between potential from one end to the other end. So that's it for the session. We understood the meaning of terms I, which is current, and potential difference. In the next session, we'll talk about in detail what is the relation between V and I and